we're going to look at rational functions. We've already talked about rational equations. Now we're going to look at the rational functions. When we discussed parent functions before, we looked at the graphs of parent functions and everything. When we talk about rational functions, these are the ones in the format of f of x is equal to basically one function over another. So p of x divided by q of x. So it's function divided by function. One of the biggest things that we need to remember, though, is that the denominator cannot equal 0. And so we have to be very careful, and when the denominator cannot equal 0, that is going to be considered an asymptote. And we'll get into this in just a moment, but we have to look at what is going to make this denominator go to 0. For example, if I take the graph of a function, for example, f of x is equal to an x minus 1 divided by an x minus 3. The graph of this is going to have a vertical dashed line here and a horizontal dashed line here, and the actual graph, or the actual curves, will look similar to this, and they'll come here. So what this graph is doing is it's going to approach positive 3 as close as it can on the right and left sides, but it's never going to touch x being 3. It's going to do the same thing to y being 1. It's never actually going to touch those. So these dashed lines are what we call asymptotes. We have a vertical asymptote and we have a horizontal asymptote. And again, we get as close to these as we can, but we never actually touch it. So in this particular case, as x is approaching positive infinity, so as we approach positive infinity, f of x, if you look at this, f of x is going to get as close to positive 1 as possible. It's not going to negative infinity, it's not going to positive infinity, it's going to get as close to this asymptote as possible. As x approaches negative infinity, f of x, so as x approaches negative infinity, f of x is also going to approach a positive 1. Now, if we look at this, f of x is approaching 1 from above on this side and 1 from below on this side. And then we could do the same thing as x approaches 3 and everything else, okay? But let's look at how we determine vertical asymptotes. Determining vertical asymptotes what we're going to do is we're going to set the denominator equal to 0. And that is actually going to get our vertical asymptote. If we have anything that will make our denominator go to 0, that will be our asymptote. For example, if I have the function f of x is equal to an x minus 3 divided by x squared minus 4x minus 5. And I want to look at the vertical asymptotes. I'm strictly going to look at this denominator. I'm going to factor it. And so where I factor x squared minus 4x minus 5, my numerator is going to stay the same. I will factor this denominator. It will become x minus 5 times an x plus 1. And so then I'll set my denominator equal to 0. X minus 5 times an x plus 1 equal to 0. So x minus 5 equal to 0 and an x plus 1 equal to 0. So x is equal to 5 and x is equal to negative 1. These are my vertical asymptotes. So if I were looking on a graph, then I would draw a dashed line at x being positive 5 and at x being a negative 1. So I would have two vertical asymptotes in this case. Now we don't always have a vertical asymptote though. Let's look at the function g of x is equal to a negative 8 divided by an x squared plus 25. This particular one does not factor, but I can set that denominator equal to 0. X squared plus 25 is equal to 0. And I can use the square root property. And I can say x squared is equal to a negative 25. Take the square root of both sides. So x is equal to a positive negative square root of negative 25. So x is equal to a positive negative 5i. If I get an I, remember that's our imaginary numbers, so I can't graph an I. And so this one has no vertical asymptote, meaning this one has a domain that goes on forever. There's nothing that I can put in this denominator that would make that denominator go to 0. So this one would actually have no vertical asymptote. Anytime you get an I, whenever you set that denominator equal to 0, it's going to be no vertical asymptote.